Welcome to today's webinar. At first, I wish all of you a good start in the new year, healthy and success and so on. Today we present the first webinar for this year. Our regular webinar, most frequently asked questions are answered by Dlubal support team. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the technical content of the website, the webinars, newsletters, and so on. I will be the moderator today, and I will also present the first part of the webinar. The second part will be presented by Jürgen. And Jürgen can introduce himself.
Yes, thank you, Andreas. My name is Jürgen Teilmann, and I'm with Dlubal Software for about 2.5 years now. I work mainly in customer support, where I answer your emails, your phone calls, your chats, and I did some research to find our most frequently asked questions we answered. So I prepared this webinar. I will present the second half, and in the meantime, I will answer your questions. And Happy New Year from my side as well. And with this, back to Andreas.
Okay, thank you, Jürgen. And when Jürgen presents, then I will answer your questions. And maybe an additional information for all who participate the first time. I've been working for the company Dlubal Software for 13 years now. We can switch off our webcams that the attendees can see the full screen. And also a short information for the attendees who participate the first time. You can show the control panel on the right side of your screen with that arrow, and then you can ask enter your question in that field, and we will answer you. You can also watch the full webinar and afterwards write us an email to info@dlubal.com. That's the other possibility. Okay, then I turn to the program, and that's the first model. And the first question is, when I start the steel design in the serviceability limit state, I get an error message that the member sets have incompatible local system of internal members. What does that mean and what should I do? At first, I would like to show you the warning message. It's also valid for other materials, also for the serviceability design for timber or aluminium constructions. So I switch here at the bottom in the table steel design. I run the steel design and get this plausibility check warning. Steel design member sets number 1 and 2 has incompatible local systems of inside members. I can press that button, switch access systems, then the program corrects that automatically, but I would like to do it manually that you can see what the program do with clicking that button. So at first I show you the local access systems of the members. Left at the bottom, I turn to the navigator display, and above you can see the members, and I check the member access systems. So now you can see the different member access systems. The access in that direction should be, or the reason for that direction should be that the model was created, or the left half of the model was created and then mirrored. I suppose that's the reason. And the steel design, or you can get problems in the steel design, at least for the serviceability limit state design, when such opposite directions in the member access system occurs. So that's the member set at the bottom, and that's the member set on the top. When I, you can see the direction, that arrow when you click with the mouse here or move the mouse in that line. I can double click it to open the member set or the settings for the member set, or I can turn to the navigator data, then member sets, and I can double click on one. That's the other possibility. So, and the menu edit member set was opened, and I click on the table here, design supports and deflections. And where you can find the check direction, and that's a quite new option, auxiliary local axis in set direction, or in the auxiliary local in Z or Y. For in that case, for the serviceability limit state design, the local axis set is sufficient. Okay, and I can do that also for the second member, but I can also select both and do it for both in one step. Okay. So, and how you can display this auxiliary axis system in the navigator display, I can uncheck this and check the member auxiliary axis systems. And now it's correct for the serviceability limit state. Those are help axes. So, and now I can run the steel design calculation. I turn to the navigator results, ratio envelope. I would like to show only the serviceability limit state. And you can see the program considers the full member length here. Okay, that's a help or auxiliary axis system. So then we turn to the next model and the next question. That's a wall, a masonry wall with an opening. And the question is, how can I set user-defined points for evaluating results on surfaces? So at the moment, where is activate, I turn to the left at the bottom to the navigator results. And you can see now the values and surfaces on grid points are selected. I can switch between grid points and FE mesh points. And you can see now where are more values because the FE mesh size is smaller than the grid. So I turn to the mesh settings, and you can see the mesh size is 20 centimeters, and that's why you get the value every 20 centimeter. So, and when I select the grid points, I can double click on the surface and take a look at the grid, and you can see the grid is half a meter, and that's why we get a value every 50 centimeter. I uncheck this and set manually such a such a point, a result point. Where you can find that? Here under types for surfaces, you can see the additional surface result points, and you can find also the button above here. I show you both possibilities. First, I do a right click with the mouse and check new additional surface result point. So then I select any point. The surface number is detected automatically. You can see that right above. I create a new point on that side, press OK, and you can see both results. And the same workflow is with the button above. I can set the different additional surface result points. Okay, so that should be also all for that model. I turn to the third model. And the question is, can I increase the loading gradually in RFEM 6? Yeah, that's possible. A cube was created that is just in balance between vertical and horizontal load when the loading is shown. Now you can see load case number 1, vertical load, 10 kilonewton per square meter. And the second load case is the horizontal load, also with 10 kilonewton per square meter. So then I select this line support, and you can see it is supported in Z direction, but there is a nonlinearity failure or if negative P set. You can also click the edit button. Now you can see this nonlinearity. The cube can be lifted up when the horizontal load is too large. And we would like to simulate that. How can you do that? So I turn to the load case and combinations. I select any load case. Now you can see load case number 1, no action category. Load case 2, the horizontal load. And the two load cases are combined without any factor in the load combination. Yeah, and to increase the load, you need the structure stability add-on. I can check this, but at first I need to take a look in the base data if the add-on is selected. Yes, that's the necessary add-on, structure stability. And I have activated it previously. So I double click on that again, turn to the load combinations, check or set this check, and I have to create a new stability analysis setting. I have to choose the incremental method without eigenvalue analysis. And with that dialog, you can increase the loading. I start with 10%. The load factor increment of 10% is okay. The refinement after last load increment 10, it's also okay. 100, the maximum number of load increments is also okay. And I activate or I enter a limit value when the load increasing should stop. And I would like to save the results of all load increments. Okay, so then I use also a special option. I consider initial state and I select the vertical load. We would like to increase only the horizontal load. So that's all with the settings. I calculate all. At first there's the statical analysis and then the stability analysis. And you can see the load will be increased until a load factor 1.01. Okay, now let's animate this. I switch to the incremental stability analysis, start with 10%. Just also take a look at the support reactions. When I increased or changed the load increment, as higher the load increment is, as higher is also that support reaction, and that support reaction is lower. So, and when I switch to 100%, where there's no support reaction and that line support, and when I increase the load to 101%, the cube is lifted up. We also present the webinar about buckling analysis, where we use this function, and this function can be used also for our stability analysis, that you can increase the load until the system collapses. At the end, I would like to show you the result or the calculation diagram. In the navigator data, you can find the calculation diagrams. So I switch to the increment stability analysis. Increment is okay, maximum deformation, and no, I used the load factor, that's better. Okay, and you can see when I at 100% load factor 1, there's no deformation, but then higher than 100%, then we get a deformation. And you can print that graphic in the printout report or directly as you want. Okay, that should be all from my side. And I hand over the screen to Jürgen, and he can continue with the third question.
Yes, thank you, Andreas, so far. I will need a second to choose the correct monitor. So you should be able to see my screen.
Yes.
Okay, just didn't show me, but okay, good. So I start with the first model of me, the fourth of the day. It's a topic about concrete, and the question is, according to Eurocode 2, I can reduce the support moment of a continuous beam. How do I consider this in RFEM 6? So what I have here is a continuous concrete beam. I just use my display navigator to hide our reinforcement, and I switch to the wireframe model as well. So we have this calculated beam, and in the navigator results, you can see on the design checks on members, I go to the ultimate limit state and just open this up. Oops, the wrong one here. You can see that I have displayed the internal forces for the bending moment for the design of this beam, and you can see the support moment over the right nodal support. It's very narrow and a high value. At the moment, this design check is fulfilled, but in many cases, because of this peak the design check is not fulfilled. So people keep asking the question I just read, and they cite from Eurocode 2, saying regardless of the method of analysis used, where a beam or a slab is continuous over a support, the design support may be reduced by an amount of delta MED. So this 96.11 kilonewton meters can be reduced according to the standard we are using here. Okay, to do this, the check, this reduction is implemented in RFEM 6. But to use this reduction, it is mandatory to have design supports. So what are design supports? I go to the display navigator and activate the types for members. And for every member, you can define these design supports, these pink blocks. And you can edit them directly via double-clicking on them. There you have this concrete type of design support with a support in the local Z-axis as well as the local Y-axis. You can edit the width and depth of these design supports. Let's say we have 40 centimeters of width and the depth may be just adjusted to the width of my beam. You can also toggle between a monolithic connection. You can see the bitmap on the right hand side of the dialog, or you can uncheck the monolithic connection. I just leave it like it is. And to assign this design support to that certain node, you can do this within the member dialog. So I double click on the member itself. And from all our tabs we have for our concrete design add-on, I go to the one most on the right where it says design supports. And you can see the design support for the start node of the member and for the end node of the member. And the one I showed you is on this intermediate node. We have a table for this. So this is node number 3 and our design support number 2, which is the one I've showed you. You can also say, I want to edit this to maybe change something. Okay, so that's the first step we need for the moment reduction. The second thing is we need to go to our ultimate configurations. I prefer to do these things, these add-on settings in the table. That's why I have increased the table. I'm in the part concrete design. I pick the second field to edit the input data. And then I go to my ultimate configurations. I double click on that. And for members in our case, because we have a member, you can see that field reductions of internal forces in Z direction. And there we have different options. And now I choose reduction of the moment or dimensioning for moments at the face of some further explanation. This is for chapter 5322 of Eurocode 2, which is the part of the standard I cited earlier. Okay, as I said, I do the check and say OK. Yes. And then I will do my concrete design again by starting the calculation. And then I just look at the model from this angle. I hide the types for members. And now you can see that the curve of our bending moment is flattened and it's a bit widened because this support moment is spread out over the width of our design support. And now we have certainly reduced the maximum of this support moment, and also the ratio for our design check therefore got decreased. Good, that's for model number 4. I will switch to model number 5, which leads me directly to question number 5, which is I have defined an additional reinforcement on a punching node. However, it is not considered in the punching shear design. What is the reason? So first of all, we now have a surface with one node. There's a column underneath, and we want to perform the design check for punching. Good. I switch to my design ratios on node. The table can be decreased in size a little bit, and we can see that our design check for punching is not fulfilled. I go to the navigator results. I go to reinforcement on nodes. I go to the provided reinforcement to show what is used in the calculation. And we have our longitudinal reinforcement in all directions on all sides of the slab being around 4.24 square centimeters per meter. And I want to increase the longitudinal reinforcement around that node. So I go into the surface with a double click. I go to surface reinforcement, and there you see our base reinforcement, which is across the whole surface. And now I want to add an additional reinforcement. So I do this by clicking on this. I do it again on this button with the star to make a new reinforcement, not on the whole surface, but via a free rectangle. I leave this material, make it a rebar, make it a smaller rebar, just an 8 millimeter every 10 centimeters, just to have a little bit of an little bit of reinforcement added to that punching node. Make it the same in both directions. And now for the direction and location of this free rectangle, I pick center and sides. For the center, I pick my punching node. And for the side, let's just start very simple with 1 square meter of additional reinforcement. You can see in our preview on the right-hand side that this should be around 5 square centimeters. Okay, yes, and leave the surface and start the punching design once more. And then you can see that nothing has changed. The design check is not fulfilled and the provided reinforcement stays at 4.24 square centimeters. Okay, to see what's the reason for this, I go to my result details of the design check by double clicking on this very line of our table. And when I go to provided longitudinal reinforcement, I just expand this by clicking on the plus, and it tells me the required length of reinforcement in X and Y direction is 1.32 meters, according to chapter 644, sentence 1 of Eurocode 2. And these values, this 1.23 meters, this comes from the minimum length you have to use for longitudinal reinforcement to use it for the punching design. And this should be at least 6 times the usable thickness of the slab plus 1 time the diameter of the column beneath it. So this calculates to a sum of 1.32 meters. You remember I have only used 1 meter, therefore this extra reinforcement cannot be used. So I now know the mistake I have made. I go back to the surface and extend this free rectangular reinforcement by editing it, going to direction and location, and let's give just a little bit extra 1.32 was the minimum. I say I use 1.35 meters. Okay, yes. Okay, and I do the punching design once more. And then you can see it's almost fulfilled. And now the longitudinal reinforcement provided is at about 10.26 square centimeters. So this is just okay. Good. Another point I want to say here when I show the FE mesh, that I used a rather fine mesh to calculate the slab, because when I now edit the mesh settings, make this a really coarse mesh with 1 meter of element length. I go to the calculation once more. That it might be that you have used the correct minimum length for your additional reinforcement, but it's not considered in the design check. So this is something you need to consider, like in every other FE analysis, to keep the mesh as coarse as possible, but still as fine as necessary. Okay, good. To our final model of today. And this is something I have to do a little bit more for the theoretical background. The question is, in a multi-surface system, I use line releases to achieve a lifting off of the surface from a grillage. Unfortunately, the surfaces get stuck in a single location. How can I avoid this? So at first I show you the model I have here. Just hide my results, go to the solid model. So we have this wooden grillage, and there are surfaces intermediate. And now what I want to do is add a behavior where I have, go back to the wireframe, where I have an uplifting force and I have another load case of a downwards force. It's the same in magnitude, but only different directions. And I want a behavior where this result is correct for the downwards, forces, so that the surfaces lay on top of the grillage. And when I have the uplifting forces, I want the surface only to be connected to the outer frame of my wood members, to have them lift off at these intermediate members. And I want to do this by using a line release. So I just model it so you can easier see the question behind this. I go to my special objects in this case, where we have all the releases. I find the line release, do a right click, and create a new line release. Okay, I want to release. Let's start from the first beam, make this one. Okay, and I want to release the surfaces around it. So these two. And now if I say okay, we'll get an error message because I haven't created a line release type right now. So I will do this here. And this is a release condition I set here. I make a release condition in z-axis, but with a non-linearity. And this should be failure if Vz is positive. Okay, I say okay, and I get a warning because I have not 100% correctly defined my line release. There are some problems with the topology of my system now. The program RFEM recognizes this and gives me some suggestions on how to repair this. Okay, I read the suggestions. It's action number 1, add definition nodes. Action number 2, add members and another surface. So I don't want to add members, to be honest, because I want to separate the surface from the members here. That's why I go to action number 1. And seems okay. I create another line release. It's just the same routine. I use the same line type, line release type. I pick my surfaces. Get the same warning, do the same action. Then when you do the same things again and again, I guess you know that by now, but just if someone hasn't heard by now, when I hit enter, I come directly to the last dialog I had before. So this is some trick to speed up your modeling. Okay, action number 1, hit enter. For the last one, it's this. Release my surfaces. And here we go. Okay, now all my line releases are defined. I calculate my uplifting forces. And this is now exactly what we had in the question I've read out before, that the system gets stuck in this very one node. All the other parts of the lines lift off as I intended it. And I just have the problem with this inner node. I just hide my results. And also in this case, go to the display navigator to hide my members to show you the logic of the logic the releases use. When you say you create a line release, is that you take that line, let's say the first one I used, it's line number 3, and you create a copy of that line, which is in our case now line number 14. You can see this by hovering the mouse over the line. If you don't see this by hovering the mouse over the line, go to the display navigator. Down to the bottom, and there's the pre-selection. If this is deactivated, just check this box and you'll have this pre-selection just as I have right now. So to get back to the point of line number 3 was the original one. With the release, I created a copy, which is line number 14. And the released surfaces now use this line number 14. And the member lies on line number 3. And so now everything I want to separate must have a doubled line or node. So I go to the other line, these are 2. Next line, these are 2. Next line, these are 2. But when I go to this node, node number 6, there's only one node. So all the members and all the surfaces are stuck to this one single node. Okay, I go back to my first line release to see, okay, it must be this definition object, definition node number 6. So this is causing the problems here. I delete it. I say okay, because I now rely on the intelligence of our RFEM, and I can rebrand this node number 6 as a definition node, which I don't want to do because I know this has led to my problems. And in action number 2, I can now add surface number 3. Okay, I will do so. Surface number 3 is the one surface on the opposite of my released line, and you can maybe you have come to this conclusion yourself, you need to release surface number 3 as well within our line release number 1. Okay, this has been done. I calculate the load case once more. And now look at that, we have the result I intended. The surface is lifting off. It's still hanging on the corner members of my frame. And when I go to the downwards load case, just to have our results complete, the surface hangs on all the members, just like intended. Okay, so these are the 6 questions we answered today. Thank you very much from my side for your attention, and I will give the hosting back to Andreas.
Okay, thank you.
Here we have it. Yeah.
Thank you for your presentation. Before I will show you the website with the recording, or where you can find later the recording and the models and the PowerPoint slide, I would like to give you a hint that you can book your free online appointment, such as a product demonstration, for any add-on or for the program itself. That's possible. Then you can click that link, or you can scan that QR code. Also, when you would like to get a non-binding offer or something like that, just contact our sales team. Okay, then I turn to the website. Our website is dlubal.com, and under news and events, you can find our webinars. All our webinars are recorded. That's the webinars of the next weeks. The Grasshopper link webinar in the next week. Then in the week after next week, I present the news in RFEM 6 and RStab 9. I present features and add-ons that we integrated in the programs in approximately in the last year. Then it follows the webinar about the geotechnical analysis add-on, then about the timber add-on, timber floor calculations, and in the middle of February follows the next FAQ webinar that we also presented today. That's today's webinar. It's already a previous webinar on our website. I click on it. In the next days, you will get a link or an email with a link that leads directly to that page here. And when you get the email, then the recording is online on that place here. You can already find the presentation slides here and also the models that we presented in today's webinar. Okay, that should be also all from my side. Thank you for your attention. Thanks to Jürgen for his presentation and for the preparing of the webinar. Maybe a last hint, when you leave the webinar, there's a small survey. Just take the minute to answer some questions. You can score the webinar. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars, but you can also leave the field empty. Okay, I hope we meet each other in a future webinar. Thank you for your attention again, and bye-bye.